How do you overcome PSRR challenges in amplifier design? Imagine trying to listen to a whisper in a noisy room. That's what poor power supply rejection ratio can feel like for an amplifier. It struggles to keep the output clean when the power supply fluctuates. Power supply rejection ratio is a measure of how well an amplifier can ignore changes or noise coming from its power source. When designing amplifiers, especially for sensitive applications, high PSRR is essential. But achieving that can be tricky, especially at higher frequencies. One of the first steps is understanding how PSRR behaves across different frequencies. Usually, amplifiers do a good job at low frequencies but struggle at higher ones. Parasitic effects inside the circuit and internal compensation networks can cause PSRR to drop as frequency increases. To combat this, engineers use power supply decoupling techniques. Placing small ceramic capacitors, like a 0.1 microfarad capacitor, close to the amplifier's power pins helps reduce high-frequency noise. Larger capacitors, such as a 10 microfarad tantalum capacitor, are added in parallel to filter out lower-frequency disturbances. Proper PCB layout is also key. Keeping the loop areas small and minimizing parasitic inductances helps prevent noise from coupling into the amplifier. Another effective approach is choosing the right amplifier topology. Cascoded stages or cascode configurations can improve the amplifier's AC PSRR by isolating the internal nodes from supply variations. Carefully designing the feedback loop, error amplifier, and pass elements in regulators can also stabilize the output against supply fluctuations. Increasing the gain of the amplifier can help too. When the gain is higher, the impact of supply noise on the output is reduced because the noise gets divided by the gain. Using low noise, low dropout regulators is another smart move. These regulators have high intrinsic PSRR, which means they help supply a cleaner voltage to the amplifier. They must be balanced carefully to ensure stability, efficiency, and low noise. At the system level, combining switch mode power supplies with linear regulators can be very effective. The switch mode power supply provides efficiency, while the linear regulator filters out high-frequency noise. Some designs even integrate supply decoupling components directly into the amplifier package, which reduces parasitic effects and boosts PSRR. Finally, measuring PSRR accurately is important. Using high-quality test setups and sensitive measurement equipment helps you see how well your design performs. Proper testing ensures that the amplifier can operate reliably even when the power supply isn't perfectly steady. In real-world applications like data acquisition, sensor interfaces, or instrumentation, these techniques help keep signals clean and precise. Managing PSRR well means your amplifier can deliver accurate, stable output signals even when the power supply fluctuates. That's the key to designing reliable, high-performance analog electronics.